And we're gonna continue with the another talk, and Jelle is gonna talk about the distributed testing and post-push review at Quora.
Good afternoon. My name is Jelle Zijlstra, and I'm here today to talk about the continuous deployment system at Quora, where I'm a software engineer. So a few words about myself first. I'm from the Netherlands, but I've lived in America for about 10 years. Most of the time I've spent working at Quora. But I'm also interested in paleontology and in open source work on typing in Python. Quora is probably a company you've heard of before. We built an internet product where people can ask questions. We get millions of people visiting the website every day. And we have about 100 developers who are continually making changes to make the product better for our users. And it's part of our culture to make it as easy as possible for people to make changes, to get into production, and to get in there quickly. So we actually have a post-push review system for most changes, where you can just push changes without getting them reviewed first, and we rely on a variety of checks to make sure that the code doesn't have mistakes before it gets deployed to production. It's also important to our culture that we track our metrics. So we actually track how often we deploy and how long it takes. Over the past week, for example, we deployed a bit over 400 revisions, 90% of them under 90 minutes total time. A few of them took longer. The current week also looks a little bit worse because of some temporary issues. But just tracking this is how we generally keep ourselves honest. Now, the first thing we do to make sure that we don't deploy bad code to production is that we run local tests. So when I push something to production, first it's going to run a couple of quick tests locally. Here's an example, something I pushed earlier today. It does a front-end change. So the first thing we ran was our TypeScript compiler, a couple of other JavaScript tests. Once that all finished, we generated a code review in Fabricator, and then we pushed the diff straight to master. After that's finished, the diff next to a system we built, which is called Santa, which is responsible for deployment. And Santa has lots of different services that deploy to all parts of our infrastructure. There's more than 100 of them, as you can see in this very long list. But the main one I'm going to talk about is the one that we call Zerg, which is the one that deploys to our web servers, as well as to a couple of other services we wrote that are in Python. In this service, we run all of our unit tests, of which there are a couple of thousand. We build a package and get it to the right place to upload it. And then we deploy to production once everything else finishes successfully. Now, my main focus is going to be the unit test step there. You can see that we run almost 5,000 unit tests. And running 5,000 unit tests in a sequential way is going to take a very long time, probably about a day. We don't want to have to wait for a whole day before we can deploy any changes. So we built a distributed system that can run many different unit tests in parallel. And this cluster is shared among all use cases for Santa, which includes our unit tests, sometimes some C++ compilation, and lots of other things. And we've built various heuristics to make sure that it gets used efficiently. On this page that we built, we can see which current steps are active and using the cluster. So as you look at this right now, there's a couple of steps, including a couple of unit tests in Zerg that are running thousands of tests. They get most of the workers. There are a few other steps active that only run a single test each, and they don't get quite as many workers to them because they don't need them. As I said, it's important for the performance of our system that we use this resource, the cluster for distributed testing efficiently. So we also have this timeline where we show what each of the workers is doing over time, so that they can see if there's any inefficiencies where, for example, boxes are idle a lot, or they do unnecessary retries or that sort of thing. You can see here that most of the time we're using it pretty efficiently. Most of them are busy the vast majority of the time, although there are some gaps where we could be using them more. Now, we hope, of course, most of the time when we run these tests, they all pass because people write good code, but inevitably, sometimes they don't. And in that case, we might have a test breakage on master. We want to get rid of those broken tests without having to always get somebody from our team to manually figure out which is the broken test and fix it. So we built a system that automatically can find out which push broke the test and then revert the diff that did it. This gets triggered every time there's a test failure. In our unit test step, it creates what we call an auto-reverter run, which then most of the time actually finishes with no action, but sometimes reverts the bad diff. And the reason that most of the time it finishes with no action is that we have actually a lot of tests that fail spuriously a lot of the time because they're flaky, they rely on something that is unstable or something like that. In an ideal world, we wouldn't have that, but we don't live in an ideal world, so instead we had to build our systems to deal with flakiness and work around it. So the first thing the auto-reverter does is when it gets triggered, is that it runs the tests again on the most recently pushed commit. So if the tests now pass on that most recent commit, we know that there's no failure anymore in production, and we don't have to do anything. So that's what happened in this example run, which we ran recently. It ran on the most recent commit, it passed, test result equals true, and then we just exited with no action. But sometimes people do actually break tests for real. Here's an example of that. Here again, we run a test on the most recent commit, as well as on a test that commit that previously succeeded on. In this case, it failed on the most recent commit. And then we start doing a search to find out which commit broke it. It's actually a ternary search because we found that works a bit better than binary search. So first we have 8 commits that could be the culprits of the breakage. Gets narrowed down to 2 after the first run. Then gets narrowed down further, and there's only 1 commit left. We know that that's the commit that broke tests. We revert it. We send a Slack message to the author to let them know that their diff was reverted. And then tests are not broken anymore. Now, the system works pretty well. It can find the vast majority of test failures and fix them automatically. There are a few limitations. It doesn't know how to deal with merge conflicts, for example. So occasionally we break a test, somebody else touches the same file before we are able to revert it. And then the auto-reverter can't fix it. We need to deal with it manually. It's also possible for 2 diffs to both break the same test file. In that case, we cannot catch both of them because of limitations in how the auto-reverter works. So it also requires manual intervention. After unit tests, we also run a Canary deployment where we deploy to a couple of production servers to make sure that there aren't any issues in the commit that aren't caught by our unit tests. And here's an example of that. We just run the code on a production server for a couple minutes, then check things like the error rate, whether enough requests have been served, and a couple other checks like that. In this case, everything was fine. And we can check at the individual tasks to see what the numbers were. In this case, for example, we deployed the code to a service called a web logger, which does some logging. There were 12 errors that happened on this web logger during the Canary period, but our threshold is 30, so we still consider the task as passing. There's just the background error rates that we gradually are trying to get down further, but it's there for now, so we have to just check if the error rate is higher than normal. And as you can see, Canary passed, so this diff then got deployed to production. You can see that happening on the main dashboard for the Zurk service. When I loaded this a while ago, the most recently pushed revision that passed all tests was something that I pushed this morning. It became deployed, and then our web servers will just pick up this new code automatically by checking for a file that tells them which revision they should be running. They check that file every couple of minutes. If they're running an older revision than they're supposed to be running, then they download the new code, unpack the package, and start running it. That happens gradually so that we don't restart all web servers at once. But after a couple minutes after this commit becomes active, everything will just switch to the new revision, and then my change becomes active in Quora production. So that's the end of the journey of my diff through our deployment system. If you have any questions, feel free to let me know, and thanks for listening today.
Thank you so much for sharing your story for continuous delivery at Quora. I wonder, I mean, it's always tempting to throw more resources in order to solve a problem like testing with distribution. And it definitely works, but obviously it comes with a lot of complexity and cost in its own, because the more things you run, the more chances to encounter a failure you have. And also your bill is growing essentially, and the time it takes to execute all this stuff grows. So my question would be is first, how do you deal with the resource efficiency? Like, do you do some sort of test selection based on the value those tests provide? And then how do you do this selection if you do?
Yeah, we don't do too much selection. Also, can you hear me?
Yes.
Okay, yeah, we don't do too much selection. There's an overall timeout, which is the main thing we enforce. No individual test can take longer than, I believe it's 10 minutes. If something takes longer than that, we will take it up with the team that owns the test to remove it and clean it up. Overall, we haven't really felt the need to go over resource usage for individual tests. Because for us, the issue mostly has been not that there's individual tests that are very resource intensive, but that there's just so many of them that they add up to taking a lot of time.
Interesting. Well, that's certainly a good position to be in. I hope, I wish we had the luxury of having ability to run all the tests. But then I have another question. So have you maybe explored some techniques for speeding things up through like, you know, there is a famous paper by Jeff Dean about taming long tail latencies, where you essentially can anticipate a failure, because when you have a lot of distributed pieces, there is very good chance that one of those pieces is going to run on a, let's say, degraded server. Maybe there is something wrong with hardware, or basically something that's causing the server to process things slower than usual. And so in MapReduce system, when they designed it, they actually would fire off a duplicate of that command, such that when the first one finishes, you can discard the second computation. In this way, you can significantly reduce the long tail latencies. So do you use some techniques like that?
Yeah, in general, we designed the distributed system to deal with failures in all of the workers. There's a couple of specific things we do. One is that for tests that we know to be flaky, we actually just enqueue them multiple times in the beginning. So that even if one of them fails, another copy might succeed. The workers send a heartbeat. They get, if they don't send a heartbeat, we re-enqueue the test somewhere else. There's various other pieces of retry logic. It's definitely been a big issue. I think we had a previous version of this system where it was very common for like one worker to break and cause the whole test run to fail. With the current version, it hasn't really been a common issue.
So you essentially do use technique. Interesting. And the last question I had is that are you using some of the publicly standardized infrastructure like Workers API or remote execution to schedule the distributed tests, or you have your own?
It's mostly just our own. There's some underlying open source libraries, of course. It uses CMQ for communication, but the way they schedule work is our own code.
Awesome. Well, thank you so much for sharing the secrets behind reliable and delightful Quora experience. I hope I'm going to see you at the panel since we're a bit out of time, so we don't have more time. But thank you so much again.
Thank you.